Lesson 8.1, identifying quadratic functions. So first of all, let's review what a quadratic function is. Remember, quadratic means squared. Because remember back in chapter 7 when we were talking about trinomials? If I had x cubed plus 2x squared plus 3, you know that's a trinomial because it has 3 terms. The highest exponent with the variable is a 3, so that was considered a cubic trinomial. But if I have, say I have x squared plus x plus 5, again I have a trinomial with 3 terms. This time the highest exponent is 2, so that's called quadratic. Okay, so identifying quadratic functions, your parent quadratic function is y equals x squared. If you graph that, you're going to get this U shape, which is called a parabola. Okay, a parabola will either face upwards or it will open downwards. Okay, if the number in front of your x squared is positive, it's going to open upwards. Okay, if the number in front of your x squared is negative, it's going to open downwards. So if you have a negative number in front of your x squared, it's going to open downwards. If you have a positive number in front of your x squared, it's going to open upwards. Okay? Quadratic functions are written in the form y equals ax squared plus bx plus c. A cannot equal 0. So let's review on how to identify the values of a, b, and c. If I give you a quadratic, say I give you y equals 4x squared plus 3x plus 2. Right? I can see that the number before your x squared is your a. Okay, so if I ask you the value of a, you can tell me that a equals 4. Okay. The number in front of your x is your b. So if I ask you the value of b, you can tell me that b equals 3. And then your constant, or just your number is going to be your c. So if I asked you the value of c, you would tell me it's 2. Let's do one more of those. If I give you y equals 2x squared minus 4, and this is supposed to be written in the form y equals ax squared plus bx plus c, what is your value of a? What does a equal? Well, a is the number in front of your x squared, so I can see that a equals 2. Let's find b and c. B is the number in front of the x. Do I have an x? No, so b would be 0. And then c is just that number by itself. So I can see that c is going to equal negative 4. Okay, you're going to want to know, you need to know how to identify the value of a, b, and c in our future lesson. Okay, here's a review of what I just showed you on that first page. When we have a quadratic function in the form y equals ax squared plus bx plus c, if a is greater than 0, that means any positive number, the number in front of your x squared, if it's positive, if a is positive, your parabola is going to open upwards. So for example, y equals 4x squared plus 7x plus 2. This number in front of the x squared is greater than 0. It's positive, so it's going to open upwards. And if a is less than 0, the parabola opens downwards. Any number less than 0 is negative. So if a is negative, your parabola is going to open downwards. Okay? So you see, if I were to graph this, I can see that the a is negative 2, so I know it's going to open downwards. Okay. How to identify a graphic function? Well, how do we identify a quadratic function? If they just give us a table of values, how do we know if it's quadratic or linear? Well, that's what I'm going to show you how to do. To determine if it's a quadratic function, we're going to be looking at differences. And by differences, I mean we're going to look at the first difference, and then we're going to look at the second difference. Here in a minute, I'm going to show you how to do that. Okay, so first of all, we have to look at our x's. What is our change in x? Because difference means change. How did we change? 0 to 1, we increased by 1. 1 to 2, we increased by 1. 2 to 3, we increased by 1. 3 to 4, we increased by 1. Your change in your x has to be constant. And here it is constant. I increased by 1 each time. And now you have to look at your y values. That's where your differences come in. Okay, I'm going to color code mine. First difference I'm going to do in red. Okay, so let's look at the difference in y's. From 0 to 1, I increased by 1. From 1 to 4, I increased by 3. 4 to 9, I increased by 5. 9 to 16, I increased by 7. That's your first difference. Okay, now we got to look at the second difference. And this one I'll do in green. Second difference. From 1 to 3, I increased by 2. 3 to 5, I increased by 2. And from 5 to 7, I increased by 2. Your second difference has to be constant. Okay? Did I increase by 2 each time? Yes, I did. Therefore, this is a quadratic function. The way I remember it is for it to be quadratic, your x is always square. Okay? But this little 2 reminds me I have to look at the second difference. That's how I remember this. Alright, so example 1, let's look at A. It wants to know, do I have a quadratic function? Well, let's look at our x values. From -4 to -2, what did I do? I add 2. Because -4 plus 2 gives me -2. -2 plus 2 gives me 0. 0 plus 2 gives me 2. And 2 plus 2 gives me 4. We have a constant change in x, so we're okay there. But now we have to check our change in our y's. So again, let's look at that first difference. From 8 to 2, I subtract 6. 8 minus 6 is 2. From 2 to 0, I subtract 2. 2 minus 2 is 0. And then I'm going to add 2. And then I add 6. Okay. There's not a constant change here, but remember that's our first difference. So now let's check our second difference. To get from -6 to -2, I'm going to add 4. -2 plus 4 gives me 2. And then 2 plus 4 gives me 6. Here I have a constant change on my second difference. Therefore, yes, it's quadratic. Now look at B. Is this a quadratic function? Is it? Well, you need to look. Is your x squared? No, it's not squared. So no, this is not quadratic. No, x is not squared. And then look at C. First thing I want to do is to graph a function when you know you want to get y by itself because y is the function. So I would have to subtract 3x squared from each side. So that's going to leave me with y equals negative 3x squared minus 4. Is this quadratic? Yes, it's quadratic because your x is squared. Okay, moving right along. Graphing quadratic functions by using a table of values. Okay. If I know that x is negative 2 and my function is 2 times x squared, if I plug in, I'm going to have 2 times negative 2 squared, which is going to give me 8. Okay. And then I would have 2 times negative 1 squared. Negative 1 times negative 1 is positive 1. 1 times 2 is 2. And then I will have 2 times 0 squared. 0 times 0 is 0. 0 times 2 is 0. And then 2 times 1 squared. 1 times 1 is 1. 1 times 2 is 2. And then 2 times 2 squared. 2 times 2 is 4. 4 times 2 gives me 8. So, here's your ordered pairs. If you need to, list them over to the side. I'll have negative 2, 8, negative 1, 2, 0, 0, 1, 2, 2, 8. From here, you're just going to plot them on your coordinate plane. So negative 2, 8, negative 1, 2, 0, 0, 1 positive 2, and 2 positive 8. Obviously this is not a line because your x is squared, so you're going to connect these dots using a parabola, using your U shape. I knew just by looking at this that it was going to open upwards because 2 was positive. Okay. B, let's graph it, but this time let's use our calculator to bring up the table. So you would put in y equals negative 2 x squared. Bring up your table, second graph. When x is negative 2, y is negative 8. X is negative 1, y is negative 2. When x is 0, y is 0. When x is 1, y is negative 2. And when x is 2, y is negative 8. Okay. So now that you have your table, you're just going to plot the points. Negative 2, negative 8. Negative 1, negative 2, 0, 0. 1, negative 2, 2, negative 8. Just by looking at this, that's a negative 2. That number in front of x squared is negative, so it's going to open downwards. And then if you graph it in your calculator, you're going to see that you get the same graph. Okay, let's talk about minimum and maximum values. Minimum and maximum values. If I tell you your minimum grade in algebra will be a 20, that means your lowest grade in algebra is going to be a 20. Minimum means lowest. If I say your maximum grade in algebra will be 100, that means the highest grade you can make in algebra is 100. Maximum means highest. Okay? So when we're talking about minimum and maximum values of a parabola, we need to look at the vertex. Okay? Vertex. That is the highest or lowest point on a parabola. So if I have a parabola that opens upward, your lowest point on that parabola is the vertex. Since this is the lowest point, that's going to be a minimum. Lowest point, minimum. If I have a parabola that opens downwards, the highest point on that parabola is the vertex. That's also known as the maximum. Okay? Maximum, highest point. Let's look at this last example. Does this have a minimum or a maximum? I can see that this is the highest point on the parabola. So this is going to have a what? The highest point is called the vertex, but it's also the maximum. That means this parabola is never going to go above this point right here. And then here I have a parabola that opens upwards. Here's your lowest point. There's your lowest point on this parabola, so that is your minimum. Okay, it's never going to go below this. That's the smallest it's going to get. Okay, finding the domain and range of a parabola. Okay, think about this. A parabola can be any real number on the x. Okay, so your domain, let's review. Let's review what we learned at the beginning of the year. Your x value is independent. That is also your domain. Your y is dependent. That is also your range. Okay? So when we're talking about domain of a parabola, the domain is going to be all real numbers. Okay? It's your range that's going to be limited. Because my range, if I'm looking at my y values, this parabola doesn't keep going above this point right here. It keeps going downwards, but it will never go above this point. So, to find the domain and range is you first have to identify the maximum. I can see the graph opens downward, so I'm going to have a maximum. To find the maximum, I have to identify the vertex. The vertex of this parabola I can see is at -1, 4. Okay, if I'm looking at your y value, I know this parabola is never going to go above 4. So the maximum is 4. So now find the domain and range. Domain is going to be all real numbers. Your range would be y is less than or equal to. It's less than because it keeps going downwards. It can be equal to 4. It cannot be more. So your range would be y is less than or equal to 4. Okay? And that's your basic introduction into quadratic functions. Your assignment on this, I didn't write it down, but your assignment is 22 through 50 evens, number 64, 65, and 66.